We have done so far, right? So we have done this Coulomb's law and all the combination, right? So we did Coulomb's law and the combination of kinematics, right? Kinematics in which we did this equilibrium, right? Equilibrium with tension, with buoyancy, right? And then with this spring force. So this way, then we calculated the electric field. Point charge, we know, superposition principle, we know. So for line charge, we calculated the electric field to be, this was, let's say, we calculated at this point. This is theta 2 and this is theta 2. So Ex was lambda by 4 5 psi 1 r, and then sine theta 1 plus sine theta. Right. And Ey was lambda by 4 5 sine 1 r, and this was cos theta 1 minus of cos theta. Right. And then we calculated at one end. So if we calculate the electric field at one end due to this line charge density, so this will come out to be this one. So this is Ex is lambda by 2 pi psi 1 r, and this Ey would be. So you see that this will also be lambda by 2 pi psi, right? And then we calculated, yeah, so then we calculated the electric field. Yeah, so you're noting down. Yes. So this is P and this is Ex. Yeah. So and then we did one question where this theta 2 and theta 1 were equal. Okay. And then we calculated the electric field due to this ring charge. Okay. So at this point, which is x distance from this ring, and the radius of this ring was A. So electric field was Qx by x squared plus k squared by power 3. So I will keep revising whatever we have learned so that you guys can do it. Yeah. And then we calculated the electric field due to half ring, and this would so at this point this would be only Ex, right? And this will come out to be, let's say this is R. So this would be, let me write it as small r. So this would be lambda by 2 pi epsilon. Okay, and then we calculated the electric field due to this quadrant. Okay. So this will have two components, Ex and Ey, and it will be similar to this line chart. So this would be Ex would be lambda by 4 pi epsilon r, and Ey will be lambda by 4 pi epsilon. Okay. So this we did in the earlier, and then you have this parallel sheet, right? So for parallel sheet, this is, so this is electric field, which is sigma by 2 pi epsilon, right? So this we did in the previous classes, right? And then we also calculated the force on a charged particle in external uniform electric field, right? So if we have some electric field, right? So for the positive charge, the force would be in which direction? Yeah, very simple question. So let's say this is a positive charge. So what would be the direction of the force?
Electric field in the direction of electric field.
Yeah, so this would be in this direction. F would be here. Right. And if I have a negative charge, so this would be in the opposite direction. Right, Faiza and Savis. So on the basis of that, you must have did. So we did one question, right? And let's say this is positive and this is negative. So this is the direction of the electric field. And one electron is thrown from this side, one proton is thrown from this side. So the crossing time you have calculated, and we found out that electron is fast. Right? This question, right, Faiza and Shahrukh.
So what is the sorry, time?
Yeah. So time taken to cross this field. So if you didn't do this question, so Amna ma'am must
Or is
have
it because of mass?
this T, yeah. T is directly proportional. This, yeah. So this comes directly proportional to root m, and this mass decides the time, right? So this mass of electron is lesser, so electron will take lesser. Yeah, you are right. So you remember. Okay, so and we did one more question. So in my class, I did this part. So in my class, what I did is that, let's say I projected the charge Q with, yeah, so this had some initial velocity. But in my class, I projected at some angle 45 degree, right? And then I calculated the velocity with which it just touches this plate. It just touches this plate, right? So we calculated and we found out that. So this question we did in the previous classes. Okay, so now in today's class, we will do the electric drive. Okay, so we have this electric dipole, right? This is minus Q, this is plus Q. And what is the direction of the dipole moment, Faiza? Yes, sir, Faiza. Do you remember the direction of the dipole moment? So this dipole moment decides the strength of the electric field, the strength of the dipole. Yeah. So yeah, I am asking that there is for electric dipole, we have a dipole whose magnitude is separation into the charge, magnitude of charge. Right. So let's say you have separation 2A and magnitude of charge is Q. So this is 2A. This you must have, right? And P vector is defined as P hat. So I am asking that what is the direction of this P vector? Or what is the direction of this P vector? Do you remember, Raisa? Okay, so if you don't remember, Chavez, do you remember what is the direction of this dipole moment?
Negative to positive.
Yeah, Faiza, you're right. So, yeah, Chavez, you are also right. So, this is the direction of the dipole. Okay, so you now know the direction of the dipole moment, and you now know the magnitude of this dipole. So, let's do two questions, very simple questions, so that you guys are comfortable enough to do all the stuff later. Right. So first, go simple question. Let's say that if I place three charges are placed And let's say plus Q charge is placed at this is A0, and minus 2Q charge is placed at 0, 0, 0, and plus Q charge is again placed at 0, A, 0. So the question is that what is the resultant magnitude of the resultant field. Right. So you guys calculate and tell me the answer. I guess that this question you guys have done in your CBC. So I'm just so that's so that you guys can remember, and then maybe do the other question. Yes. Today, what my goal is that I want to start. Okay, so many of the people are not here. Tariq is not
So
here.
that plus Q
Yes.
coordinates at 0, A, 0 plus Q.
Yeah, plus Q is 0, A, 0. 2 plus Q. There are 2 plus Q. One is A00, the other one is 0A0. Okay. Yes, so most of the people are not here. Tariq is not here, Vidya is not here, Shahid is not here. And we have okay. So I will keep the class, so today's class for 1 hour, right? Because we then the other people will miss. Okay, guys.
Yes.
Yeah. So okay, that's all. Let me draw the diagram so that you guys, yeah. So this is, and one charge is placed at here. So this is minus Q, right? The other is placed at here plus Q, and this distance is, and the other one is placed. So this is X, Y, Z, and the other one is placed at plus Q. So you guys have to find what is the resultant dipole moment, right? Yeah. Anyone got the answer? Yes, Faiza and Chavez. Oh, thank you. The idea is that you have to find. That is why I. Yes. Is
This
it
is 0.
0? Okay, so Chavez answer is 0. What about Faiza answer? So what is your answer, Faiza? So let me give you a hint, guys, that you have 2 dipoles, right? Just find those 2 dipoles, write the direction of those, and then press start. Yeah, Faisal. Okay, so let me solve this problem and you check your answer first. Okay. Yeah. So you have 2 dipoles, right? One is this plus Q, and we can divide this as minus Q and minus Q. right? So we have two charges which are minus q and minus q. So we have one dipole. We have one dipole which is this. Oh, this is very clear. We have one dipole which is this, and we have another dipole which is. So one is like this, right? And the other one is and both has same separation, same magnitude. So the magnitude of these two dipole would be same. So what is the direction of this dipole, Chavez? Yes, Chavez.
Negative to positive.
Yeah, so upwards, right? And the direction of this dipole is phasor. In which direction? Negative to positive, yeah. So, right. So you have two dipole, which is one is this, the other one is this, right? So we have two dipoles, this one and this one. So parallelograms law, right? So this would be the resultant. And the magnitude of the resultant would be root of, let's say, p prime. Let me write it as p prime. So magnitude would be p square plus p square. So 2p square. So root 2p. Any doubt in this problem? Okay, so further did you get the same answer? Oh, yeah. So I will do one more problem, which is exactly like this, and then I will move to the electric field. Yeah, you guys want to note down this part. Okay, so please note it down and then we will do one more. Yes, noted, everybody.
Yes, sir.
Yes. Okay, so let us do one more problem, which is exactly like this. So we have an equilateral triangle, right? And minus 2q charge is placed here, and plus q charge and plus q charge is placed here. So what is the magnitude of the resultant that way? Right, same question. Yeah, you guys please try that and tell me the answer.
Then it's equilateral triangle.
Yeah, equilateral triangle. Okay, so let me, yeah, you got the hint. So
Is it root 3p?
Root 3p. Okay. Yeah, so Shave's answer root 3. What is your answer, Faizan? What did you get? So the idea is that we have to just find the individual dipole and take the result. So what did you get, Faisal? P root 3, yes. So same. So Faisal answer is also. So you guys, yeah. So you guys are correct. This is P, right? This is P. So the resultant would be something like this. So this would be P prime would be root of P square 2p square cos of 60, right? So cos 60 is half. So cos 60, this cancels 3p square. So yes, or good guys. So okay, so now we understand the electric dipole. Now you guys have already learned about this. So you guys have already learned about this electric field due to dipole. Right, so you guys have calculated the electric field due to dipole at 2 points. One is this, that you have this dipole, and one point is this axis line. This line is very clear. So this is at this point, and this is called the E axial. Right, guys? And you have this bisector line. So this is 2A, right? Yes, sorry guys, I got disconnected, sir. Sorry for the interruption. Yes, guys, can you hear me?
Yes, sir.
Yeah, I got disconnected. Sorry about that. So yeah, so let me share my screen again. And where was I? So I was talking about this electric field due to the axial point, right? Okay. So and the important please move this window. Okay. So the important thing to remember that the electric field due to the axial point, right, is in the direction of what? Yes, Chavez. This electric field at the axial point is in the direction of what?
Dipole.
Yeah, dipole. So this is in the direction of this dipole. Right, correct. And due to the equatorial point, so what is the value of the electric field at the equatorial point? Yeah, do you guys remember?
Minus
So
KP by R.
yeah, minus absolutely correct. Minus Kp by R cube. So this goes, so this also varies as 1 over R cube. So one thing we need to remember that the electric field due to the dipole varies as 1 over R, right? And for the equatorial part, this is against the direction of the dipole. So E equatorial is against, E axial is in the same direction. Understood, guys?
Yes, sir.
Okay, now so now let us understand what is the electric field. Electric field at the general point due to dipole. Okay, general point meaning that I have a dipole, right? So this is a dipole and the separation is 2a. And I want to calculate the electric field at this point. At this point, right? So this point is making an angle theta with the dipole. Understood, guys?
Yes, sir.
So what I will do is that I have this dipole moment, right? I have this dipole moment which is in this direction. So I will break this dipole in two parts. One would be this P1 and the other one is this P2. Okay. Understood, guys?
Yes, sir.
So I have this electric, so this, so in the direction of this dipole moment, I have this electric field E1, and in the direction of this P2, I have this electric field P2. Okay. And the resultant of this is this. So this is, let's say, this angle is theta, right? And this angle is theta, and this angle is phi. Okay, understood, guys?
Sir, what is E1? Like,
Yeah,
surplus charge.
yeah. So let's say that at this point, who left? Okay. So at this point, I have one electric field which is in this direction. Okay. And other electric field which is in this direction. Understood?
Yes, sir.
So the net electric field would be the sum of or the resultant of this electric field. So this is the E I need to calculate. Understood?
So can just once again explain how we got this direction of electric field.
How did I get the direction of this E?
Electric fields E1 and E2.
E2, yeah. So we have, let me draw this again. Okay. So I have this minus Q charge, I have this plus Q charge, and I am calculating the electric field at this general point. This is theta. Understood? So I am saying that one electric field is in this direction. Right, I am calling it as E1. And one electric field is in this direction. Okay, and the angle is this phi. Understood? So this is the net electric field, resultant electric field. Understood?
Yes, sir.
Yeah, yeah. And these one, so these one are perpendicular, right? Understood? Okay.
Yes, sir.
Yeah. So this is the angle theta. So we know that what would be E net? E1 and E2 are perpendicular. So what would be E net? What would be E net? E1 and so let me write it like this. We have E1, we have E2. Right. What would be this E net? Yes. Vector algebra. Chavez and Faisal. Vector algebra. Oh, you guys have. Okay, so you guys have forgotten. This is E1 square, E2 square, and 2 E1, E2, and cos of 90. So this cancels. We have simply E1 square and E2 square. Am I correct? Am I correct, guys?
Yes, sir.
Okay. Now I will calculate what is E1, what is the magnitude of E1, and what is the magnitude of E2. So you guys tell me that if I have this dipole, right? If I have this dipole, and whose magnitude is, let's say this is theta, this is P. So this would be how much?
90 minus.
This is theta, this is theta, this is P. So this would be how much? Correct.
Yes.
And this would be how much? P2 is how much?
P sin.
P sin theta. Okay. And now you tell, yes. P sin theta. Yes, Faisal, absolutely correct. So only in calculating the general, I am doing the derivation. You guys just need to remember the formula, but I am showing you guys that how do you get this. So this diagram is only the important part. When you guys can understand this diagram, then you can solve, then you can find the electric field at the general point. So you guys tell me that if I have this P, this is cos theta, right? And I'm calculating the electric field at this point. So what would be that? What would be that? What would be the magnitude? Yes, guys. What would be the magnitude?
Because it has 0 degree.
No. I am just writing that the magnitude of dipole moment is P cos theta. Okay. So this would be K P cos theta by RQ. Am I correct or wrong? Right. So this would be Kp cos theta by R. And let's say that I am calculating the electric field. This would be 2 kV, right?
2 kp,
And
right?
Yeah, 2 kb, right. So, and let's say I am calculating the electric field at this point, and the magnitude is P sine theta, and this is the electric field that I'm getting. So this is E. This was E1. So E2. So this is what point? Can you guys guess? I have this dipole moment, and I'm getting this electric field. So this
Equatorial.
is equatorial, correct? So this would be how much?
Minus KP.
Yeah, I'm only talking about the magnitude. So Kp sine theta by r. Understood, guys?
Yes, sir.
Okay. So now we can we know what is the value of E1, what is the value of E2. So we can just plug in the values and we will get the answer. So this is 2 Kp cos theta. So 2 Kp and Kp and R cube are common. Right. So I can take it outside. And this would be 4 cos square theta plus this is how much? Sine square theta. Understood, guys?
Yes, sir.
So this would be Kp by r cube, and this is sine square theta is 1 minus cos square theta. So cos square theta, 1 minus cos square theta, 4 minus 1 is 3, right? So this would be Kp by r cube, 1 plus 3 cos square theta. So this is the magnitude of the electric field at the general point. Any doubt in this, guys? Faiza and Chavez, I can explain it again if you guys have any doubt. Any doubt?
Can just explain once again, sir. Just.
Okay. So as I have told you, the important part is this diagram. So this diagram we need to know, right? So we wanted to calculate the electric field at this point, right? So what I did is that I know that for the axial point, I know. For the equatorial point, I know that this is in this direction. And for the axial point, this is in this direction. Right? This we know, right?
Yes, sir.
So what I did was that I broke the dipole moment in 2 components, P2 and P1. Okay. Understood?
Yes.
And then what I did is that I calculated the electric field at this point, E1, and I calculated the electric field at this point. So you can see that this is the dipole moment and this is the electric field. So this is what scenario? Axial or equatorial? Yes.
So which one, sir?
Yeah, P2 and E2. Which scenario? Axial or equatorial?
Equatorial.
Equatorial, right? So then I wrote the value of E2 as Kp sine theta by r because P2 was P sine theta. And then I calculated the electric field in this direction, in the direction of the dipole moment. So this is what? Equatorial or axial?
Sir,
Axial. So, and my value of P1 is P cos theta. So I calculated the electric field as the axial electric field, 2 Kp cos theta by r. And then E net would be, so these two fields are perpendicular. So E net would be just the square of these. Right?
yes, sir.
So then I calculated the electric field as this. Understood? Now understood. Any doubt, Faiza and Chavez?
No, sir.
Okay, you guys, please note it down. You guys, so just this diagram is the important part. When you can draw this diagram, then the finding the answer will be simple. Faiza, Did you understand? Do you want me to explain this again? Okay, you are saying that you want to explain me, you want me to explain or you understood? Which, so understood, yes? Oh, okay. Yeah, you guys have please note it down. So we calculated the magnitude and then we will calculate the direction. So this is the electric field at the general point of the band. Right, you guys learned about the equatorial axial. So whenever, so in the exam, in the JEE exam, they can ask the electric field at the equatorial or at the general point. So whenever you guys need me to scroll down the screen, please tell me and then I will scroll. Because today many people didn't join, so what I will do is that I will keep my pace here, right? So what I wanted was to write just write those formula of the general point. But yeah, so but that is not clear, right? Okay, should I scroll down the screen, guys?
Yes, sir.
Okay, noted.
No, sir.
Okay. So the next topic would be torque on electric dipole and then electric flux, and I will start electric flux and application of force. So I guess that in the next two classes, this chapter will be over. Right. So do you guys think that you would be able to solve all the problems of the first chapter? Do you guys find the confidence?
So can I repeat?
Yeah, so do you guys think that you would be able to solve the problems of the chapter one? Yeah. Did you guys get the confidence?
We have to practice.
Yeah, okay. So practice, right? Practice. But I think that I have done all the types of the equation, right? So I think you guys will be able to. So yeah, practice more and yeah, have some confidence. Okay, so did you guys note it down? Done. Chavez and Faisal. Sure, Faisal has written. What about you, Chavez? Done.
Yes, sir.
Okay, so just remember that E1 is 2 kp cos theta and E2 is kp sin theta by I. So we calculated the magnitude, right? But the direction is also important. Right, so just remember again the diagram. I will keep revisiting this diagram because this diagram has all the answers. So minus q plus q, general point, right? And the electric field was this E1, this is theta and E2. So this one and this one. So this one. Right. And this is the E net. Right. So this is the angle phi. Okay. And this is the direction of the electric field. So what would be the direction, guys? This tan phi would be how much? Vector,
E2
vector.
by 1.
Yes, yes, right. V2 by E. Thanks, Shah. So this is V2 by E1. V2 was how much? V2 was, I guess, Kp sine theta by, yeah, V2 is Kp sine theta by RQ. Kp sine theta by RQ. And this is 2 Kp cos theta by RQ. Right. So this cancels, and we have tan theta by. Understood, guys?
This is the direction, sir.
Yeah, this is the direction. This phi is the direction, right? This phi is the direction. Okay, so you guys have please note it down and then we do two questions based on this problem. Noted, guys. Yes, done, guys.
Yes, sir.
Okay. So now let us do some problems. So there is one question which says that the electric field at general point is perpendicular to the dipole moment. Right. Find the relation between theta and phi. Okay. So this is the question. Did you guys understand the question?
Yes, sir.
Yeah. Yeah. So please try this question and tell me the answer. Let me draw the diagram. Let's say that we have this is the dipole moment, right? And this electric field is perpendicular. Okay, this electric field is perpendicular. E net is perpendicular. So you find what is the relation between this theta and the phi. Yes, Feza, did you understand this question? Yes. So find the relation between theta and phi and also value of theta. For what value of theta, this electric field will be perpendicular at the general point. Yes, Feza, did you understand the problem? Okay. Yes. Chavez, did you understand the problem? Yes, sure. No. Okay. So yeah, Feza. You see, so please you look and whenever you find that if I'm correct, so please right. You please check your answer. Size. So this is the electric field, right? And this is theta, and this is phi. Right? Right, Chavez, am I correct?
Sir.
Yes. So by looking into this diagram, you can see that phi plus theta is how much? Yes, how much? Theta plus phi is how much, Chavez? When this electric
90
field is,
degrees.
yes, 90 degrees. So phi would be 90 minus. Understood? So this was the
Yes.
first part. And now let us calculate the value of this theta. So we can use this formula. Tan phi is tan theta by 2, right? And phi is tan of 90 minus theta. This is tan theta by 2. So this is cot theta, which is tan theta by 2, right? So tan theta is 1 by, oh, cot theta is 1 by tan theta, right? And this is tan theta by 2. So tan squared theta is 2. So theta is, or tan theta is root 2, and theta is tan inverse root 2. Okay, okay, guys, understood. Any doubt? Yeah. So this is the answer. Did you get, Faisal? Yeah. So yeah, Chavez, understood.
Yes.
Your guess was hesitating, right? So
Yes,
I
sir, I
will.
understood.
Oh, okay. Okay. Please note it down. Okay, done. Faisal has noted it down. Chavez, please note it down. Whenever you have noted down, please tell me. Yes, Chavez, noted. Done, Chavez.
Yes, sir.
Okay, so you guys just take these two questions as you, right? So first, this question that this is dipole moment vector P, and this is making an angle 60 degree with the x-axis. Okay, so you guys need to calculate what is electric field at a distance A from this point. Okay, and this dipole moment vector is making making an angle 60 degree with this x-axis. So you guys calculate what is the magnitude of. Okay. Did you understand the question? Yes, Chavez and Faisal. Understood the question?
Yes, sir. We have to find the electric field.
Yeah, electric field at the x-axis, which is a distance at this point. Right. A distance from
Yes, sir.
origin. Okay, and the second question is the simple one. So you have this line charge density, right? And its distance is L. Okay, and you have this perpendicular bisector. So you have to calculate the electric field at this point, which is a distance from this line. Right. From this line, and you calculate the electric field, right? And A is root 3L by 2. Okay. And the hint is, for this hint is that the general point diagram. This is the hint. And for this hint is that your EX is what? EX is lambda by 4 pi epsilon 1 R plus sine theta 1 plus sine theta 3 and Ey is lambda by 4 pi epsilon r cos theta 1 minus cos theta 2, and your theta 1 is equals to theta. For this case, this is theta, this is theta. Okay, did you guys note down this question? So this is question 1, question. Please try this question and send me. Okay, guys.
Yes, sir.
Okay, so we will stop at here, right? What I wanted was to do this problem. This torque on electric diode, but I will keep it for the next class. Okay,